Hi folks, welcome back to the Pre-Cal 40S videos. In this one we're going to start Chapter 3 and we're going to look at polynomial functions, outcomes R11 and R12, and in this we're going to look at factoring polynomials of degree greater than 2 and less than 5, where all the coefficients are integers, and we're also going to graph and analyze polynomial functions which are going to be less than a degree of 5. So first off, we're just going to look at the characteristics of polynomials. A polynomial is a function of the form where you've got f of x, you have a coefficient, that's what our a sub n's are. So a sub n minus 1, that's all of our coefficients here. And then you've got x to the power of some number. So let's say we start at x to the power of n, and then it goes to the power of n minus 1, and then these descend as it goes on. Now, n in the exponents and in the subscripts here, those are all whole numbers. So that's where we have 0, 1, 2, 3, etc. Goes up from there. X, those are our variables. All right, so we've got x to the power of 2, 3, 4, whatever, and it goes down as we go this way. And a sub n all the way to a sub 0, those are real numbers. Now, if you notice right here, this doesn't have an x variable attached to it, so that actually ends up being our constant. So these here are some examples of polynomials. Notice here this is a linear function, it's a straight line, and this is a parabola, it's to the power of 2, and this is a polynomial, and it has the highest power is 3, and then we've got them listed descending from there. And here we've got a y equals, and it's a fifth power polynomial, so you've got x to the power of 5 and plus 7x cubed minus 1. So the similarities and the differences, what we have to be able to do is classify what a polynomial function is, and let's have a look. We are going to use some new vocabulary. We're going to talk about the end behavior. This is where the y values end up as the absolute value of x becomes larger. So we're going to use the language, it extends up or down into quadrant 1, 2, 3, 4. Okay, so that's the language we're going to use. We're looking at, when we see the word degree, we're talking about the largest exponent of x. So up here, this one, this is a 5th degree polynomial because the highest power of x is a 5. This one up here is a 3rd degree polynomial because the highest power of x is a 3. The constant term. Now, the constant term is the term without the x, and it is also the y-intercept. The leading coefficient is the coefficient of the term with the greatest exponent. So if you list everything in descending powers of x, it'll be the very first coefficient that you see there. So if I just go back up to these examples, the leading coefficient here is 3, the leading coefficient is 1, this is also 1, and these are, well, those are all 1. That's kind of not that exciting, but let's do a couple more examples on the next page and hopefully it will be more exciting. Okay. So in these examples, we're going to identify the functions that are not polynomials, and we're going to state why. If they are a polynomial, we're going to state the degree, the leading coefficient, and the constant term of each of the polynomial functions. So first off, if we look right here, we notice that it's got a square root of x plus 5. This is what ruins it for the polynomial classification. So here, this is a radical. If we were to write it in exponent form, we'd end up having x to the power of a half. Now, notice that this power of a half is not a whole number. Therefore, it cannot be a polynomial. Okay, now this one here, this is the absolute value of x. This is an absolute value function. It has a corner, or it's pointy. So if you notice when you draw the absolute value, you end up getting a point. Some definitions of a polynomial are that you have to draw the whole thing in one foul swoop, I guess you can say, or you can't lift the pencil off the paper, and also there are no pointy parts on a polynomial. It's all a smooth curve everywhere you go. This also cannot be written as x to the power of n. So it is not a polynomial. Now this one here, we've got 3x to the power of 4. Polynomial function of degree 4. So the highest power on the x is 4. The leading coefficient is 3, and the constant term is 0. So there isn't anything else afterwards, so we assume it's a plus 0. And in this final example here that I'm giving you is a third degree polynomial. The highest power of x is a 3, and the leading coefficient is 2. So here, this is the leading coefficient right there. All right, and the constant term is a -1. All right. Now, there are some questions here. I want you to try these, so please pause the video and try the next few, and then I'll reveal the answers. Okay, so now here, the first one is not a polynomial. It's a rational function. If you rewrite it as with x as a power, it's to the power of -1. -1 isn't a whole number. The second one, this is a fifth degree polynomial. Leading coefficient is -2, and the constant term is 4. If you didn't look at this carefully and you just kind of did this question really quickly, you want to rewrite this in order. So you go -2x to the power of 5 plus 3x squared plus 4 if you're writing it in descending order. So then you could see the answer a little better that way. And this part C, this is a third degree polynomial. Leading coefficient is -4, constant term is 3. And finally on this one here, this is a radical function, so you've got, you could just look at it right here. The power is 1/3. It's not a whole number, therefore it's not a polynomial. All right, so I'm going to continue this lesson on the next video. All right, see you soon.